Hi, Mr. Richards here. Today's 8th grade Unit 1, Lesson 13, Anchor Problems, and we're going to focus today on computing with scientific notation using multiplication and division. And so in problem 1, one sheet of 8.5 by 11-inch paper weighs 4 5/10 or 4.5 times 10 to the negative third kilogram. The school is expecting a delivery of 100 cases of paper, which include a total of 5 times 10 to the fifth pieces of paper. How much does all the paper in the cases weigh? Well, a lot of information here. And so if we just take out what's important, we have 4.5 times 10 to the negative third kilogram is what one sheet weighs. We know there's a total of 5 times 10 to the fifth pieces of paper overall. So we don't need to worry about the size. We don't need to worry about the number of cases. We just need to take these two numbers and do what? Well, each paper weighs this. There's this much paper, so we're going to multiply. So we're going to multiply 4 5/10 times 10 to the negative third. We're going to multiply that by 5 times 10 to the fifth. When you're multiplying with scientific notation, let's multiply those 4.5, or 4 5/10, times the 5. We're also going to multiply the 10 to the negative third times 10 to the fifth. 4.5 times 5 is 22 5/10, or 22.5, and that will be times 10 to the negative 3 plus 5 is 2. Now this looks like it's in scientific notation, but it's not. This is not a final answer. It's not in scientific notation yet. In scientific notation, you can only have one number to the left of the decimal point, not two. It's a common mistake. Right now, first example, stop it if you think this is right. It's not right. You need to rewrite this 22 5/10 as 2 25 hundredths. Now, we can't just do times 10 to the second. We took this and made it a factor of 10 smaller. We move it over once, a factor of 10 smaller. So we need to make this a factor of 10 bigger. So that's times 10 to the third, a factor of 10 bigger. And that's our answer, 2 25 hundredths times 10 to the third kilograms, what these 5 times 10 to the fifth pieces of paper, these 100 cases of paper, are going to weigh. Continuing on to question 2. The speed of light is approximately 300 million meters per second. The sun is approximately 1.5 times 10 to the 11th meters from Earth. How many seconds does it take for sunlight to reach Earth? What is this in minutes? First thing I want to do is take my 300 million and rewrite it in scientific notation. And so to do that, our decimal point currently is here. I'm going to go 1, 2, 3 strikes, you're out. Okay, 4, 5, 6, 7, 8. Takes me 8 to get to where that 3 is to the left. So this is equivalent to 3 times 10 to the 8th. Now, there's a little formula that we've used in the past. Distance equals rate times time. Mrs. Wilson would be happy with this. What's our distance? It's 1 5/10 times 10 to the 11th. That's going to equal our rate, which is this 3 times 10 to the 8th, multiplied by our time. Well, now I have a one-step equation. Let's divide by 3 times 10 to the 8th on both sides of this equation. Cancels out on the left or right side, excuse me. On the left side, 1.5 divided by 3 is 5/10. 10 to the 11th divided by 10 to the 8th, subtract the exponents. 11 minus 8 is 3. So 0.5 times 10 to the third is my time. But here's the thing. Again, this is not in scientific notation. I need a number to the left that's not 0. So I need to rewrite this as 5 times 10 to the something. Well, if I went 1 over to the right to make this a factor of 10 bigger, to balance that, this needs to be a factor smaller. So times 10 to the second. And that's how many seconds? 5 times 10 to the second seconds. Now, in order to get this to minutes, I'm going to be dividing by 60 seconds in a minute. And it's helpful, this is our first part of the answer here, it's helpful to say, well, this is really, if I look at 5 times 10 to the second, that's really 5 times what? 100? To be 500 seconds. And so if I'm looking at 500 seconds, and I divide it by 60 seconds in a minute, that is going to be, I'm looking at my paper here, there it is, 8.3 repeating minutes, which is 8 1/3 minutes. A third of a minute is 20 seconds because there's 20, 20, 20 to get to 60. So this is really 8 minutes and 20 seconds. So when you look at speed of light and how far it is from the sun to the earth, it takes 8 minutes and 20 seconds for it to travel all that distance to go from the sun to the earth. Problem 3. A student multiplied 2 numbers in an online scientific calculator and got the following result: 1.5e plus 20. What does this answer in the calculator mean? What are possible factors that the student entered into the calculator? Well, let me tell you, what this really means is it's a big number, obviously, but this means 1.5 times 10 to the 20th. That's what it translates to be. And when you look at possible factors, I'm looking at that 1.5, and I'm thinking that's close to 15. Well, when I say close to 15, I mean if I move this decimal over, right? If I move that decimal over once, this should be like 15 times 10. This got bigger, this gets smaller, 19th. Okay, what are some numbers I can put in there to get to 15 and 10 to the 19th? That's my next part. Well, for the 15, I can look at that as being 3 times 5. And for the 10 to the 19th, what are some numbers that add up to 19? Remember, we're going to be times 10 to the means I'm going to have to add the exponents. Well, let's keep it simple. What if this was just 10 to the 10th times 10 to the 9th? Because 10 plus 9 will get me that 19. And so I'm going to say, in my infinite wisdom, which is really not much, that we could take 3 times 10 to the 10th and multiply it by 5 times 10 to the 9th in order to get this 15 times 10 to the 19th, which is equivalent to 1.5 times 10 to the 20th, which is what it is in this calculator here. Now, just wait, there's more as I scribble on the page. If we look at the calculator, ooh, look, this is going to look very similar. Hey, look, it's a Google calculator. 3 times 10 to the 10th times 5 times 10 to the 9th. If I hit equals 1.5e plus 20, hey, look at that. It's the same thing, 1.5e plus 20. And we took 3 times 10 to the 10th times 5 times 10 to the 9th. We got that, which is equivalent to this, which is equivalent to that. There you go. Let's keep going. Now, problem 4 summarizes pretty much everything we've done in this lesson, so it's a really good question. How do you calculate with scientific notation when you're multiplying? How do you calculate when you're dividing? First step here is this division problem. So let's take first 6.6 divided by 1.1. All right, 6.6 divided by 1.1. And the other part is 10 to the 7th divided by 10 to the negative first. All right, 6.6 divided by 1.1, and 10 to the 7th divided by 10 to the negative first. All right, 6.6 divided by 1.1 is simply 6. And then 10 to the 7th divided by 10 to the negative first, 7 minus negative 1 is 8. This is 6 times 10 to the 8th. And now we're going to multiply that by 3 times 10 to the negative 5th. Perfect. Well, for this question, we're really looking at, if you split it apart again, I'm going a little bit slower on this last example. You look at 6 times 3, and you look at 10 to the 8th times 10 to the negative 5th. Well, 6 times 3 is 18, times 10 to the 8 plus negative 5. Remembering our laws of exponents here. 8 plus negative 5 is 3. Again, 18 times 10 to the 3rd is not in scientific notation yet. It is not in scientific notation. This has to be 1.8 times 10 to the something. Now, the decimal point is originally here. We made it smaller by a factor of 10. To balance this, has to be bigger by a factor of 10, so times 10 to the 4th. 1 and 8, 10 times 10 to the 4th. And so, to summarize this lesson here, as you look to multiply that 4.5 and the 5 here. Then you add the exponents, but make sure you're in scientific notation in your answer. When you're dividing, subtracting the exponents, but again, make sure you're in scientific notation in your answer. Calculator one was just kind of there to really expand our imagination and know what happens when you type in and how that relates to scientific notation. And this last problem 4 here, really, it breaks down our division and our multiplication and making sure our final answer is in scientific notation. The number one mistake with these isn't in the calculating steps, it's in the final steps typically. Are you writing your final answer in scientific notation? If you are, great. If you're not, something to work on. That's it for this lesson. Good luck.